Yeah, so in this lesson 2, we're going to talk about translation, eccentricity, and the discriminant, and also how to rotate, how we do rotation of the x-axis, the x and y-axis. Yeah, so maybe the first thing, so let me just say this is our lesson 2, hoping that we do finish the topic, unit 1. So the first thing we're going to learn, so these are, I can just categorize these to be properties rather of conic sections. Okay, so from everything else that you learned, we had those general equations, the standard ones that we're discussing. Now, there is the first thing we're going to learn here today is the eccentricity, this term, eccentricity. Yeah, so this is just a number that we consider that shows, or rather that identifies, the conic section that we are dealing with. Just a special ratio really between the foci and the vertices, how they overlap, like how the degenerate relation of ABC is going to be in each particular case. So by ABC, you remember, like under, should be, is it under ellipses, we said something like this. An ellipse, we said if you have something like that, the bigger one is always what? Your major diagonal, those things that we're discussing. So by A and B, I mean this. Then we're saying for an ellipse, C was always the bigger one. We had what? We had A squared, then we had plus B. We had something like this. Then for hyperbola, we said A was the bigger one. Yeah, so these ratios, how A, B, C interact, will give us the ratio of our eccentricity. So whenever the eccentricity, this is denoted by small letter E, whenever it's equal to 1, whenever the E value, the ratio is equal to 1, it simply means that you are dealing with a parabola. Now I'll show you how to calculate the E value, but here let's just talk about the properties first. Then whenever the expression that you're going to be given is, so if E, for an ellipse, we always say it's C over A, and the E that you're supposed to get is less than 1, then we know we're dealing with an ellipse. That's how you know to say it's an ellipse. Yeah, that's how we know. Then the third property I may mention is that for a hyperbola, E is also equal to C over A. That's a ratio. And in this case, you know that C is always greater than A. So the eccentricity value should be greater than what? Should be greater than 1. Yeah. So E is just technically, let me just say the general thing here. E is equal to C over A. That's like the general formula, yeah? Even for parabola. So these are the key things you just have to remember. The value of E can tell you which type of conic section you are dealing with. Yeah, so this is going to help us to trace whatsoever we are dealing with. Yeah, so an example, a quick simple example here is as follows. Without even knowing the equation, so here they're saying identify the conic sections centered at the origin and given the following values of A, B. So they've given us A to be equal to 2, and then B is given to be 5, and here they're saying what? The second one, B, they're saying A is equal to 3 and B is equal to 1. I wanted to just a minor ratio that shows us, or rather that identifies the type of conic section that we're dealing with. And whenever the eccentricity is equal to 1, we say it's a parabola. Whenever it's less than 1, meaning we're dealing with a what? We said what here, Charles? Whenever it's less than 1, what did we say? Hello, Charles. Were you getting what I was saying? When the eccentricity is less than 1, it means what's a conic section? We said whenever it's less than 1, we're dealing with an ellipse. Yeah, so here, meaning we're dealing with an ellipse. Then here, whenever it's greater than 1, this is simply direct going to be a hyperbola. Yeah, so you notice that for a circle we do have, but then the ratio between A and C, they should be the same. So so sometimes there's confusion between this part here. But do we have a C when it comes to a circle? So there's that, you know, that whole debate. So we don't have, it's easy for you to tell when you're dealing with a circle. Yeah, because of the radius and a few translation, which is just the center being moved from the origin to another point. No other modifications are so complex for a circle. But for these, we need to be specific. And this is one way that we can tell the conic section that we're dealing with. And a simple example I was trying to illustrate here is where we have A is given to be 2 and B is given to be 5. Now, there are only two possibilities here. C is obviously going to represent some point for a foci of the focus point. And the checking that we're going to do here, the formula that we're going to apply is always assume that C is the longest guy. So if I may use another board, so okay. Yeah. So A is 2, B is 5. So we're saying always assume this case. This is the best case scenario where C is the longest side. Yeah, that's the good possibility you must think of. And if you want to get the C in this case, we'll put our 2 there. I was asking you to have your calculators nearby, because this is now going to give us what, 25 plus this, that's going to be 29. So C is basically the root of 29. That's what we are having. So we're going to check. We say the formula for eccentricity is what? Is C over A, right? So E is equal to C over A. So your C is root of 29. Your A is a 2. So when you divide this, what you get, already you're able to see that this is going to give you something that's greater than 1. Yeah, so meaning you're dealing with a hyperbola. So this is how we check using eccentricity to try to identify, to picture the type of conic section that we're dealing with. Yeah, so we'll be taking this case all the time because it's the best case scenario. Yeah, C, which is the foci, is assumed to be, for these shapes that we have, C is always on the outside part. So meaning it's supposed to be the longest side as compared to the other guys that we have. Charles, are you getting what I'm saying on this part? Yeah, so let me just say example 2. So they are saying, I'll read the question here. A hyperbola of eccentricity E 3 over 2 has one focus at, so one of the focus, let's call it F1, -3, that's what you have. The corresponding directrix, so they're saying this is a hyperbola. Corresponding directrix is the line y is equal to 2. Find the equation of the hyperbola. So find the equation, that's what they want. So you shouldn't be shocked that here they are mentioning about a hyperbola having a directrix. Even hyperbolas have directrix, because the definition of the directrix is just the distance, the equidistance between the foci and the vertex to another point. So that's basically where we find the directrix. So even a hyperbola can have, if I give you a hyperbola that looks like this, and there's a distance here, let me just use a different color. We said if this is the foci, this is F2, one of the focus point, the distance from here and the distance from here, let's say, has to be the same. So meaning we can have a directrix here. Even this side you can have the same. Yeah. So I know to say we talked much about directrix lines when we're discussing parabolas. They can also apply when we're dealing with a hyperbola as well, according to the definition of the directrix it can fit. Yeah, so this is the question that we are given here, and remember we always get E is equal to C over A, so meaning C over A is equal to 3 over 2. Then here they're telling us to say we have a line that looks like this. This is our at y is equal to 2, y is equal to 2, which is somewhere there, we have a directrix, meaning we have this, the foci here is 1, negative 3, 1 on the x-axis, negative 3. There's a 1, negative 3 somewhere there. So we have something like this, meaning this is actually turning down like that. Yeah, so the distance between the distance from here, these are 3 steps coming down and 2 steps here. So I mean this is a 5. This distance gap here is a 5, right? So meaning the foci, also here they said the foci, sorry, this is supposed to be something like this. We know to say this is a 2, right? This is a 3. This point here is supposed to be the foci. It's supposed to be inside. So what's the gap in between here? So this has to be at somewhere here. Half of 5 is what? 2.5, right? So this is 2, then this is at 0.5, negative half. So we're supposed to have the expression has to be like this, the turning point, because this distance has to be the same as that distance. Yeah, so maybe to just show you how we can solve such a question, we know to say, according to this equation here, the ratio of eccentricity, C over A, is equal to 3 over 2. So we can have the first equation, which is just 2C is equal to 3A. This is equation 1. You can keep it. Then they are saying the distance from the directrix to the focus is supposed to be the distance from the directrix to the distance, this whole distance is supposed to be a 5. That's what we need to know. The distance has to be a 5. We need this guy here. So they're saying is simply the same as, I can write this equation here. So distance from, let's say, directrix to the focus. The easiest way we can just find it is just saying we have what? The C. So we can just say, how can we say this? The total distance. So here it's going to be 5 units. We calculated it. It's just like we did 2 minus negative 3. That gave us 5. Okay, so here is a question, Charles. They're saying, let me read it here. A hyperbola of eccentricity E is equal to 3 over 2 has a focus at 1, negative 3. The corresponding directrix is the line y is equal to 2. Find the equation of this hyperbola. So this we're given. That's a question. So I was trying to explain how you can try to imagine this. It's like you're trying to write your free body diagram to illustrate where the focus and where the directrix are going to be. The directrix is at y is equal to 2, which is this line there, and the focus is supposed to be mukat, like it's supposed to be engulfed, sort of. So it's supposed to be inside here. So I didn't have these points here. So just saying the 1, negative 3, this point is supposed to be squeezed inside. So our turning point is somewhere there. Then the focus is inside. Now we know to say the distance from here, from the directrix to the focus, since we know to say we moved down by negative 3 steps, and here we moved up by 2 steps, meaning the units here are 5. That's where the 5 units is coming from. And I got it by just saying 2 minus negative 3. So this is where the 5 came from. Then, to find where we are turning here, we're going to simply half the 5 units. So if we half the 5 units, it simply means that we're going to be at negative half. That's how I got the negative half. It's confusing here, Charles, right?
I think just because we didn't do an example in class, so I was trying to follow the formula which he gave us, which he gave us in class. So this was I was meaning behind.
Oh, maybe.
Okay. Yes.
Yeah, so okay, I'll give you another simple example, because here once you get the 5 units, so already have this equation, because the formula here, the only formula we have is for eccentricity, which is 3 over 2. So when you cross multiply, you get your 2c is equal to your 3a. So we can make this to be your first equation. Now this distance, the 5 that we got, we could have just gotten it by just saying the focus minus the ratio between what? A over eccentricity. Because if you say A over what? A over eccentricity is C over A. Right? So this is the same as what? This is the same as the focus from, how can we say this? This is supposed to be, oh yeah, the distance is supposed to be equal to 5. So we are equating the distance between the focus and the initial point that we are having is supposed to give us our 5. So this is supposed to be 5 here. Now we already know what eccentricity is. How can I say this? Okay. Yeah.
This modular thing.
Yes, so, yeah, the modulus. Oh yeah, they're supposed to put the modulus. So yeah, so the first thing, if I may just run you through this, the verbal thing is that eccentricity is just the distance to the focus over the distance to the directrix. That's eccentricity. That's basically eccentricity. So now, if we equate the ratio, eccentricity is already given to us. It's 3 over 2. So now we know that 3 over 2 is supposed to be equated to what? To C over A. That's what we're interested in. So the distance is supposed to be 5. Yeah. So now if the distance is supposed to be 5, the relation we're supposed to make is going to give us 2 equations so that we solve for the 2 unknowns. So let me just write it for you here. Moses, you're able to get me now, right? Moses, can you see the screen now? We were saying, once we have the relation between these two, the equation that we are forming is just relating to what eccentricity means. So the first one, we formed it by equating this part here. This, we already have it, and you can make C to be the subject here. So if C is the subject of the formula, that's going to give us what? C is equal to, is it 3a over 2? Yeah, you can form this. Then we said eccentricity is equal to the distance. According to the definition, we say the distance, let me just give it to you here. So we say the distance to the focus divided by the distance from the directrix. Yeah, so this is for a hyperbola with the relationship is just between these two. Yeah, so the whole 5 that we got according to the modulus, we're supposed to write it as what? We're supposed to write it as okay, for the sake of the video, I'll just write it as C plus A. Then down I'll say C minus A. That's for this conic section. Instead of using D, can I break it down for you to see it? I want to find a better, simpler way to write it, because they introduced D in your notes and I don't want to use the letter D because you have only been using A, B, C. Yeah, okay, so how about we formulate, can I say? Okay, this same equation here, this same guy that we're having here. Now, where there is a C, remember C we've said it's same as 3a over 2, right? So here, pali C, I'll put 3a over 2, then minus, minus what? It's supposed to be minus E is the same as, E is the same as what? E is the same as C over A again, so we can just have what? This now is now going to make things a little bit, it's supposed to be A only, because I was supposed to multiply throughout by E. Yeah, so this is supposed to be A alone. Okay, how can I say this? Okay, it's okay. We can have A over over what this is supposed to be, because E is C over A, that's going to be A over C, yeah, is equal to 5. Let's see if this is going to work out. Now we know what C is. C is what? 3A over 2. So again, I plug it down. That's going to give us 3A over 2 minus, this is going to give us A squared multiplied by 3 times. Okay, maybe I'm doing too much shortcuts. So A is C over A. So when you are dividing with a fraction, you can just flip the fraction into the reciprocal, just to change it into multiplication, right? So instead of writing E down, I'll just write multiply by A over C instead of C over A, because that's what E represents when we flip it down. Then Pali C, I was supposed to write C, we've said is the same as 3A over 2. Now because C is at the bottom, I'm just going to write A times A, that's A squared. So C is supposed to be 3A over 2, but because it was down and I'm changing into multiplication, it's going to be 2 over 3A. That's going to give us what? A 5. Yeah, so 1A here goes with 1A there. So I'm having 3A over 2 minus 2A over 3 is equal to a 5. And if I may, we can what is it? We can find this is 6. That's going to be 9A minus this is going to give us 4A is equal to 5. So we can cross multiply. You have 9A. This has to be this is going to give us 5A, right? Yeah. So 5A is equal to 30, meaning you have 5 there, you have 5, implying that according to this, your A is equal to what? Your A is equal to 6. Now in your notes, they did it in a different way, but the answer they got is 2A, which is equal to 6. So once you get your A is equal to 6, you can find your C, because remember E is equal to C over A. They already gave us this 3 over 2, so meaning is C, A is 6. You can get this, so you can multiply. That's going to give us what? C is equal to 9, because 6 by 3, that's 18, divided by 2, that gives us a 9. Yeah, so I'm guessing you are lost here, Charles, but I'll get back to a proper example when we do your tutorial sheet. So once you get your A, B from the centricity that you are given, you can now find the center. So the center is supposed to be 1,6, which is the middle part. So I'll come back to this because you are given 1 and what? 1, -3. Yeah, so the center is where we find the middle point between the two pieces that we need. Yeah, so remember there was a 1 here, right? 1, -3, meaning the other portion as well was also somewhere there. So now we're looking for the center where these 3 guys are supposed to be, sort of like pakat. Yeah, so that's the center. Then the vertex of the other guy will be given. Yeah, so the equation, let me just go straight ahead to the equation. Since you have your A, your B, and your C, what they wanted was just the equation. So the equation is supposed to be the guy that has a longer, this is facing up, meaning the major axis, or the A is on the y-axis, so meaning y was the bigger one, so y minus the center being 6, then the longest side, which is this is B, that's going to be 36, then minus x, the x coordinate, which is 1. Okay, so I'll give you another example. This is supposed to be how is it becoming a 45? Because we're multiplying, or 15 by this. Okay, so we're looking for, this is your A, then this is your B. We're looking for B, so this is 45. Then this here will give us a 1. Okay, so this is technically the answer that we're supposed to get. Now, I'll come back to this. I'll give you another example. I know this may be a little bit confusing because I just throw things at us, how to play around with the eccentricity. Now, my main concern why I wanted us to do this class is for me to explain what translation and how we can rotate things. I'm doubting we'll go up to polar coordinates. I think I'll just record them, then send the video. But here I'm concerned with this part, the translation part. So translation is not even a big deal. The big deal is on the rotation part, how to eliminate the XY term for you to be able to identify the conic section. Yeah, so I'll start with reminding you of the general equation that we did. So remember this equation that we talked about at the beginning of the course, the topic. There was this equation plus cy squared, then plus there's a dx plus ey, then plus f is equal to 0. Remember this equation, Charles, right?
Yes.
So now, using this same equation, we can actually apply it before we even rotate or translate anything. We can use this same equation to do what we call the discriminant test. Yeah, so I'm not trying to follow your notes. I'm just going to follow things that the order that is going to make you understand this easily. So the discriminant test, remember how the discriminant is from your 1100. The discriminant is what? 4AC. This is according to this, I'll use capital letters. That thing that this guy, the one that is found in a square root for ABC, in that Chimabas equation, so it's the same thing, just that here we're using capital letters. So now the value of the discriminant can tell you the conic section that we're dealing with. So whenever the discriminant b squared minus 4ac is equal to 0, it simply means that you're dealing with a parabola. So I'll just say P. Then when the discriminant is less than, so when this guy is less than 0, it simply means that you're dealing with an ellipse. Then number 3, whenever we're dealing with, whenever the discriminant for C, then this is greater than 0. Whenever you're dealing with a hyperbola, that's when it's greater than 0. So this is just how we get to know. Yeah. So all those general equations, the standard equations we're looking at. So even if they give you this equation, before you even translate it, before you rotate anything, so the whole idea of you rotating is to eliminate this, the xy term, the term that has x and y attached. That's the whole essence where we're going to need to rotate or translate. Translation is very easy. Translation is not as complex as as it sounds. It's just you being able to reform the equation into something you're familiar with. And we can only translate when the xy term is not present in the given expression. So I'm going to give you examples. Okay, yeah. So, so translation of coordinates. Are you okay on this discriminant part here? So we're saying before you solve, before you even start solving, you can have an idea of the conic section you are dealing with, so that if you get something different, if your conclusion is going to be different from what the discriminant is giving you, meaning you made a mistake somewhere. So this is just like a guide. As you are working out, your answer must be matching what conic section the discriminant has told you. That's why we need this. Not that I'm teaching you here. I know in your notes they teach it after you do rotation, but here I want you to know this already. It's important that you know this so that before you solve, you even have an idea of what you are looking for. So now it's easy. Please take note that you can only carry out translation if there is no xy term. That's what this. The xy term is this term here, this term here, this term, the term that has a coefficient of b. That's when you can translate. And whenever the term xy is present in your expression, you cannot translate it. Hence, you have to rotate the expression, or rather rotate the conic section. After you rotate it, the xy term disappears. Then you'll be able to translate it and determine the conic section that you have. So let me give you an example for both cases. Yeah, so I'll try to teach these concepts together. So I'll give you an example here. This is translation. So examples, I'll give you 3 of them. At least you'll be okay. So we call it translation of coordinates because we don't change anything. We just want to put it in a different form. And this is very easy. It's something you are familiar with. You used to call this completing the square. Yeah, so I'll give you the 3 examples that I'm going to give you. I'll list them here so that you just screenshot them. Then we start solving them. There's 2x squared minus y squared, then plus 6y is equal to, this is equal to a 3. And the second one, 4x squared plus y squared minus 8x, then plus 4y minus 8 is equal to 0. Then the last one is x squared plus 2y, then plus 2x is equal to 1. Okay, so like for the first one, I'll just get this first one. So for the first one here, we are told that we're dealing with, we want to translate this so that we can get the conic section. Now, what's the B here going to be? What's your A according to this? According to our standard general equation, what's your A? The one that I'm just from giving you on the discriminant.
2.
Your A is 2. So you have your A is 2. Then your B, is there a B?
No B. There's no B.
There's no B, right?
Yes.
So your B is 0, right?
Yes.
Then your C.
6.
What's your C going to be?
6. It's going to be 6.
You're sure it's going to be 6?
Oh, sorry. Is it 0? 0.
C is supposed to be the coefficient of y squared. So C is -1. Remember this guy here.
Yes, I remembered.
Yeah.
Looking at it now.
Yep. So A, B, C. Then D is the coefficient. We don't need D. We just need what? We just need A, B, C, right?
Yes.
Yeah. So according to our question, what's going to be our discriminant when you solve it? So here your question says what? You're having, this is at the back. Your A, we said it, so if you do the replacement, okay, so your B is 0, so you're having 0 minus your B squared, 4. Your A is what? Your A is 2. Then your C is -1. So here you're getting 8. It's greater than 0, so we're expecting a what? A hyperbola, right?
Yes, hyperbola.
Exactly. So we know to say, even as we are solving this, as we are trying to translate this thing, this question here that we are having, the equation has to look like the equation of a hyperbola by the time we are done. Yeah, so solution on question 1, how do we translate it? So this is not complicated. We're just using your completing the square formula or method. Yeah, so like I said last time, you have to gather the letters. So like here there's what? It's like I can just say this for the sake of solving. It's like there's 2x. Can I say this? Okay. It's like there's 2x squared plus 0x minus y squared then plus 6y is equal to 3. So that I just get to have to complete this. If I complete the square here, that's going to give me 2. I'm having x squared plus 0x. Then here I'm getting negative y squared minus 6y is equal to 3. So I'll complete the square of this part and complete the square of this part. So it's going to be 2. Then there is x plus a 0 squared, then minus a 0. Then here I'm just going to get y minus 3 squared minus a 9, the square of this guy. This is a 3. Are you okay up to this point here, Charles? You remember completing the square,
Yes.
right? Yeah, so this is just going to be the same as 2. Okay, for the purposes of just solving, so just say x plus 0 minus, this is y minus 3 squared and plus 9 is equal to a 3. Yeah, so according to this, this is going to give us what? This is going to give us, I can take this on the other side. This will be 2. I can just say 2x squared. Yeah, then this is y minus 3. This is squared. This is going to be negative 6. Now, we cannot deal with this negative here. So I'd rather multiply everything with a negative 1 so that I get rid of this negative there. So I'm going to get negative 2x squared plus y minus 3 squared is equal to 6. Yeah. In short, some people won't even do this. So just say, okay, remember how a hyperbola, the discriminant told us to say we're supposed to get a what? A hyperbola. So a hyperbola needs to have a 1 after the equal sign. So how do I get rid of the negative 6? I cannot take this on the other side. Remember the general expression of a hyperbola is supposed to be, let's say, x minus h squared, there is a squared, minus, let's say, y k squared over b squared, let's say, is equal to 1. This is the expression of a hyperbola that we need to get. So we cannot move negative 6 on the other side. So the only option we have is to divide everything by negative 6 to attain a 1 after the equal sign. So divide by negative 6, divide by negative 6, divide by negative 6. That's a simpler thing I can say. So that 1, 2 there is 1, 2 there is 3. So I have x squared. I'll have, okay, my board is tripping. Okay, I can have negative 3 plus y minus 3 squared over 6 is equal to 1. This can be changed. I bring the positive this side, so y minus 3 is the positive 1, so we're on the y-axis, then minus x squared over 3 is equal to 1. So this is the equation that we're dealing with. Is this okay? So some people say no, instead of writing this, they can easily just write this. Use capital letter y to the power 2 over 6, then minus x to the power 2 over 3 is equal to 1, where, just write where, capital letter y is equal to small letter y minus 3, then capital letter x is just equal to small letter x, because there is no movement, it's 0 movement in the x-axis. So all they want to see is this general equation here for the hyperbola. Of course, you can proceed to sketch it, get the directrices, get the asymptotes, those things that we did under hyperbola, but this here is your equation. Your a squared is equal to 6, meaning a is equal to root of 6. Your b squared is the smaller one, which is 3, meaning b is equal to root of 3. You can get the rest of the information and try to solve it. So yeah, this is translation, just needs you to reach up to this point. So the main skill you need for translation is just completing the square, that's all. And you need to do the discriminant first, at least to have an idea of what you're expecting to get. Is that okay, Charles?
Yes.
Yeah,
Okay.
so yeah, let me do the next one, the other one. So here, the next guy, I want to do the discriminant. We'll do the discriminant afterwards so that we see if you will be able to get the correct conic section. So part
Is it
B.
okay if I put just a screen a bit? I don't know if it's going to get time.
Okay, no, it's okay. Okay, so for B, which is just going to be, this is 4x, then we have plus y squared minus 8x. Again, it's the same thing really. We just, so I won't do the last one. I think I'll look for something that has rotation. Yeah, so that we end on rotation. At least you'll be able to get something important tonight. So here again, we gather like terms. We did this. We gather this guy and that guy. So have 4x squared minus 8x, then plus y squared plus 4y. Take the 8 on the other side, becomes positive. And here you just have to deal with the 4, factorize outside. This is a 2a. Then you have, this is just the way it is, y squared plus 4y is equal to 8. Then this is just going to be the same as here. You're just having, you're going to get what? We're completing the square, right? So this is going to give us something we are familiar with. So this will be 4 outside waiting. Then we have x minus 1 squared, then minus 1. Then plus, this is just y plus 2. And minus 4 is equal to 8. So multiply back the 4, that's going to be 4. X minus 1 squared minus 4. Plus, this is y plus 2, the power 2, minus 4 is equal to 8. Then this is just 4, x minus 1 squared, then plus y plus 2. This is equal to 8. This is 4 and 4, that's negative 8, goes this side, becomes positive 8. Yeah, so we have 4, x minus 1 squared, y plus 2 squared is equal to 16. We can divide both sides by 16. Let me just check this here. To make 1 here, this will be 4 there is 1, 4 there is 4. So it will be x minus 1 squared over 4 plus y plus 2 squared over 16. That's going to be equal to 1. This is what? An ellipse, right? There's a plus sign on the middle. A squared is 16. This is the same as x minus 1 over 2 squared. Yeah, and then there is y plus 2 squared. 4 squared is equal to 1. So yeah, this is an ellipse. Yeah, so that's the conic section. So the discriminant has to give us the same. So you can just check at your convenient time. Yeah, now what if we have xy, the xy term? We have to do rotation, which is my main goal of this topic. I mean this lesson today. Yeah, so this part is okay, Charles. Can we do an example on rotation, right, before we end our class?
Yes, okay, but there's the part that ask.
Yes, yes.
How have you identified director at this ellipse that testing?
Okay, because of the general equation of an ellipse. A general equation of an ellipse always takes the form this a squared, then y squared is b squared is equal to 1. There's a plus here, pakat. Then for a hyperbola, there's a minus somewhere. There's, let's say this. That's the difference. Hyperbola, there's a minus. Ellipse, there's a plus. They are both positive, yeah. So even this side is positive. Here, one of them has to be positive, one negative. It's okay. Yeah, so now whenever we have an equation that has an xy term, we have to always rotate it. And now rotating it needs us to know by what angle we are going to use to rotate it. So yeah, so this is me going to explain here. So they'll always state the angle of rotation. Yeah, so it's like, so the whole idea of rotation is like, how can I say this? Okay, maybe let me say you have yeah, I have this. This is a normal setup of a hyperbola. Then if you want to rotate it, let's say you want to rotate it at a particular angle, so meaning one portion goes there, the other portion goes there. You've seen that we've rotated it somewhere, it has gone like this. So yeah, I don't know if I wish I could do this in person, but yeah, we're rotating this. It has moved. So from this, it has moved with a certain angle to this guy here. Even the asymptotes have also changed. Yeah, so we've rotated it. So there should always be an angle stated. And whenever an angle is not given, we can use the equation that you have to get the angle of rotation. Yeah, so the angle of rotation that you get is always going to be given with the formula cot 2 theta is equal to a minus c over b, or rather we just say it's the same as tan 2 theta is the same as B over A minus C. This is how we get the angle of rotation all the time. Yeah, it's easily done like this. Then the replacements of X and Y, I will explain these where they're going to come from later on. For now, I just need you to know how we use them. There are two replacements that we're going to be making. So the replacements is that we have what you call, you have Y prime. Y prime is going to replace X. So let me give you this. So there's X will be replaced by X prime cos the angle minus Y prime, then sine the angle. Then Y will be replaced with, so here it's what? Again X prime, then we have sine theta, then plus Y prime, then cos theta. So rotation can happen in two ways. So if something was already rotated and we want to get back, we'll replace with the other formula. So where there's Y prime, we'll replace with, it's like we'll make Y prime the subject of the formula. That's going to be X, then sine theta, then minus Y, then cos theta. I'll give you both examples to explain what I mean. Then X prime is X, then cos theta, plus Y, sine theta. So if you want to rotate something, you use this formula here. But if something is rotated and you want to bring it back to what it was, you use this formula here. Now, for you guys doing MAT2100, they use X and X prime. For you guys BENG doing 2110, we use U and V in place of X prime and Y prime. So whichever letter that they use, the combination, the formulas are still going to be the same. And please don't forget how we get the angle here. Yeah, so let me, how can I show this? I want to give you a perfect illustration. And the whole essence of doing this is that by the time we are done, the XY term has to be eliminated. Yeah, so okay, this is a perfect example I'm going to give you right here. This is going to be our last example that explains rotation of axis. So this is rotation to eliminate the XY term. Yeah, so eliminating XY term. So here it means that XY term is present. So if you want to eliminate it, we use these combinations, these formulas here. But if there's no XY term and you want to bring it back on board, we use these set of formulas here. Hope you are getting here, Charles. Yeah, then don't forget the formula for the angle. It's tan 2 theta. Let me just write it here. Tan 2 theta is equal to B over A minus C. The A, B, C are coming from the general equation. So here's our example. They are saying for the equation 2x squared plus root of 3xy plus y squared minus 10 is equal to 0. I'll give you the question here. So I'll say eliminate. So find the angle. Find the angle of rotation. Eliminate xy term and identify the conic section. Now, this is the reason why I even taught you how to find the conic section using the discriminant, because like I said, before you even start solving, you can use the discriminant and determine the shape that you are dealing with. Now, according to this question here, your A is 2, your B is what? Your B is root 3, and your C is what? Your C is 1. Are you still with me, Charles?
Yes.
Okay. I know it can be a little bit too much, but yeah, this is your calculus for you. Yeah. So it's too much, huh?
No, I just have a question.
Yes.
Okay, may I ask a question?
Pardon?
Or maybe first you finish, then ask.
I know, ask here so that at least if it's here, I clear it in advance. Maybe you may need the information for the other solving we're going to do.
Okay, so for the angle, this formula, can you use any formula, whether tan or cos, there's no any effect, right?
Oh, yes.
You can use any for the angles.
You mean like, can you use tan or cos?
Yes. Or
no.
there's a specific way of using.
Oh, this is the specific. Oh, the other one was cot. It was not cos.
Yes, cot and tan, yes.
Yes, cot. You can use either. It's the same thing.
Yes, it is what I wanted to ask. Again, okay, scroll down. Consider those two formulas when it's rotated and it's not rotated. Do they mention so that you know it's supposed to use this one? Yes, this one.
Or you look at the question, then you know what you do. So if the question has XY term, meaning you have to get rid of it. Then if the question doesn't have XY term, meaning you have to put it there.
You have to put there.
Yes, so this.
Okay, thank you.
So we use this to eliminate. We use this to put. So look at the question. The question has XY term. So we have to eliminate it. They said eliminate.
Okay.
You've seen it come?
Yes.
Yeah, so the question will guide you. When they say eliminate or rotate, they mean one and the same thing.
Okay.
Yeah, that's what they mean. So hope that's okay.
It's okay.
Yeah, so okay.
Then I can just see the question. I can just see the question top. Just top on top.
Okay, so let me just take it back here. Okay, so the question. Okay, so this, I don't know why I wrote this. I'll just try giving you formulas.
No, those formulas, I just want to know the one for elimination and the one for. I just want to.
Oh, okay. These guys.
Right. Alright. Alright. We can proceed.
Okay. Okay, so you look at the question. So here we want to proceed to eliminate this term here. Then identify the conic section. Now we can do that before we even eliminate this using the discriminant. But then we won't do that. We'll just use the discriminant to verify what we're going to get. Yeah, so we have identified our A to be 2, our B to be root of 3, and our C to be that. So we can get the angle first. That's the first thing we're going to do. We get the angle of rotation. Now, sometimes the angle can be stated in the question, but if it's not stated, meaning you have to get it, and that's the reason why we're doing this, so that we get the angle of rotation. Yeah, so according to my calculation here, if I have, so let me write it here, that's 2x squared, then I have, at least you guys are allowed to use calculators, so it's pretty much not going to require knowledge of trig or anything. You just go direct. So yeah, this is very straightforward. So here now we're going to do what? We're going to get the angle first. So that's going to be tan 2 theta is equal to, we said it's what? It's b over a minus c. So your b is root 3 over a minus c. That's 2 minus 1. So this is the same as root 3. Yeah, so what is tan 2 theta is equal to root 3. So 2 theta is equal to tan inverse of root 3 gives you what? So 2 theta, this should give us a 60 if I'm not lost, according to what I remember in trig. Then divide by 2, meaning my theta should be 30. Is this what you're getting, Charles? Tan inverse of root 3. Hello, Charles. You got 30 on your calculator, right? Like, okay, you got 60, then divide by 2, right?
Oh, I didn't leave that side. Cut it before it.
Oh, okay. So we're just starting to solve it. So we just got here to replace, to say the formula is tan 2 theta is equal to b over a minus c. Yeah, so this is going to be root 3 over 1. So now we are just saying this part here can be solved when you do your tan 2 theta to be equal to root 3. Then you say 2 theta is equal to tan inverse of root 3. You get your answer to be 60 on your calculator. Then divide both sides by 2. You're simply going to get a 30. Is this part okay? Hello, Charles. It's okay? So once you get this angle, you go back to those equations we used to say, we say that those equations we use when we want to eliminate, do the elimination. So the equations are going to always be solved prior to us substituting them in the equation, the question that you're dealing with. So the equations, we said what? The first equation, the first set of equation, when we're trying to eliminate the xy term, is the one that has my prime. Now instead of my prime, I'm going to use u and v. Yeah, so v will represent x prime, then u will represent y prime. That's what I'm going to use. Then I'll replace them at the end when we're done. Yeah, so the equations are pali x, we're supposed to write so where there is x prime, I'll use v, so this is v. Then cos, where there is theta, we're supposed to put the 30, so we need to put the 30 minus u. Then this is going to be sine 30. Then where there's y, we're supposed to put v sine 30, then u cos 30. Hello, Charles, you're saying something?
It's bouncing here. It's bouncing here. My slime for you. Okay, don't you fix it? Hello. Oh, there's a girl playing the music, so I think it's the one. Sorry.
Oh, okay.
Yes, I wanted to turn it off, to reduce the volume.
Okay, so are you okay on the v and
yes,
the u? So now if you punch this on your calculator, I just want you to do this in advance so that we just do the replacement. So if you punch cos 30 on the calculator, what do you get? According to our special angles, yeah, what's cos 30? The special angles, preferably. What do we get for cos 30?
Is it 2 punch, or maybe I use that square root of 3?
Square root
the
of,
special angle.
Yeah, the special angle. So it will be root 3 over 2, right?
Yes.
Yeah. Then sine 30.
Sine 30
is half. Is it not half?
Sine opposite of hypotenuse. Yes, half.
Yeah. So again, we have this and v, then plus. We'll have root of 3 over 2 with the u. So these are the replacements we're supposed to do. So we just converted this. Yeah. So now we're going to go back to our original equation, the question itself. So the question itself is 2x squared plus root 3. Then there's xy plus y squared minus 10 is equal to 0. So we're just saying wherever there's x, we'll put this whole thing. Where there's x, we'll put this. Where there's y, we're also going to put this. By the time we're done solving, we should only have v and u, and there shouldn't be any place where we should see v and u multiplied, because we remember we've said where there is x and y, x is representing v, y is represented by u, just that we're representing these guys, the guys that have primes, so just to distinguish them. Yeah, so we're just having 2, where there's x squared, we're going to put root 3 over 2, put a v, minus 1 over 2 with a u squared plus, there's a root 3, then now I'm multiplying root 3, 2v minus half u and half v plus root 3 over 2u, then plus, where there is y, we put 1 over 2v plus root 3 over 2u squared, then minus 10 is equal to a 0. Are you okay up to this point?
Yes.
Yeah, so now we just solve this. We're just trying to solve this so that we're able to get rid of this part here, the middle part. So let me use white. White is better. Yeah, so I'll expand this part. So I'll just do my shortcut. You can do it clearly at your own convenient time. So this multiplying itself twice, that's going to give me 3v squared over 4. Then this times that, then times 2, that's going to give me, so I'll put negative, I'll say root 3, this is vu, then I'm going to write a 2 down. Yeah, so I'm multiplying this by itself, then the last one to be 1 over 4, then u squared. Then here on the middle, I'm going to get root 3 is going to be waiting here. I'm going to multiply everything inside first. So this is the part where people lose it, because this process is very tedious. You really have to be sharp and focused on what you're writing, because any silly mistake, your XY term won't cancel. You have to start again. So this is why people feel lazy answering this question, and it always comes in your quiz 1. Yeah, so this times that, this is root 3 times 1 over, this is root 3, this guy here times that, that's going to give me a root 3 v squared over 4, then this times that, that's going to give me plus a 3, then there's a 4, this is vu, then this times that, it's going to give me minus 1 over 4 vu, the last one is negative, yeah, this times that, that's going to give us root 3 over 4 uv again. Yeah, then the last one, the last part is expanding this. It's going to be 1 over 4 v squared plus, that's going to give us root 3 uv over 2, then plus, that's going to give us a 3 over 4 u squared minus 10 is equal to 0. So for now, I just want you to copy this, Charles, because of time. You'll go through it at your own convenient time. You've copied?
I've copied it.
Okay.
Yes.
So now I'm going to multiply by 2 everything, so that 2 multiplies this part. So 2 there, that's going to give us 3 v squared over 2 minus, that's going to be root 3 vu, then 2 times that, that's going to give us 1 over 2 u squared. Then here I'm going to multiply root 3 by everything. So root 3 times this, that's going to give us a 3 just v squared over 4, then plus 3 root 3 over 4 vu, then this times that, that's going to be negative root 3 over 4 vu minus, that's just 3 over 4, then uv. Yeah, then the last here, I won't have to change this, I'll leave it the way it is, 1 over 4 v squared plus root 3 over 2 uv plus 3 over 4 u squared minus 10 is equal to 0. So now our concern, remember, is v and u attached. They have to cancel. We don't have to see u and v attached at any particular point. So we'll get the like terms. Let's see this and that and this and that and this. Are they giving us a 0? So if they're not giving us a 0, meaning we've done something wrong. So I'll just get the numbers. I'll just get negative root 3 minus root 3 over 4. then this is going to be another minus. Minus what? This is minus. Okay, one has. Okay, this is 3. This is a 3 root 3. 3 root 3 over 4. Then there's a root 3. So here, how many are you going to get? So the last thing that you have is a plus root 3 over 2. So here, let's see if this is supposed to give us a 0. Let's see if this is going to give us a 0. Common denominator is what? Is 4. This into that is what? That's negative 4 root 3. This is going to give us negative 3 root 3. This is going to give us negative root 3. 2 there, that's going to give us what? Okay, have I made a mistake somewhere? This is positive, negative, negative, that's negative. Then this is going to give us 2 root 3. This is what? This is giving us something. Okay, this is positive. The 3, this is positive. Sorry, this is positive. Yeah, this is positive. Yes. So look at negative 4 plus 3. That's going to give us what? That's going to give us negative 1, right? Negative 1 and this. So I'm going to get negative root 3 and negative root 3, then plus 2 root 3 over 4. So you're noticing that this will be negative 2 root 3 plus 2 root 3 over 4. The top guy is a 0 over 4. You notice this is a 0, okay?
Yes.
Yes. Okay, I know this maybe. Here, have you seen the math I've done here on top? This is positive, that's negative, positive, negative, negative, then positive. Yeah, so this, that, and that, and that, and that are disappearing. That's the whole idea of elimination. So that at this point, the part that is giving us the xy term gets to disappear. This is okay, right?
Yes, okay.
You're sure here, Charles? It's okay, or you're lost on my...
Like the way you've done, the way you've separated it, it has made sense.
Yeah, so this is easy because once excuse, you have to check first before you progress, because if the part is not cancelling out, meaning you made a mistake somewhere, there's no need of you continuing. So this is how I use to check whether I'm on the right track or not. So once that cancels out, I can now proceed to ignore everything that has v and u, or rather x and y, and I'll just write everything else. So I'm going to go with 3v squared over 2. Then I come here, I have plus 1 over 2 u squared, then plus there's a 3v squared over 4, then there's a plus this guy here, 1 over 4 v squared, then plus the 3 over 4 u squared minus 10 is equal to 0. Now just gather the like terms. Anything that has v, that's x, right? This part. For lack of better terms, hope this is going to be okay, because that's like what? 1.5 plus 0.25 plus 3/4. So what do? So we can just add this. What's 3 over 2? That's 1.5 plus this is 0.75 plus this, which is 0.25. It's going to be 0, remainder 1 is 12. It's going to be what? This is 12, 13, 14, 15. Remainder 1, that's going to give us 2.5. Okay, that's the same as 5. 5 over 2 v squared. Then for you, this part and that part, that's 0.5, 0.5, this half, and 0.75. There's a 5, there's a 2, then there's a 1, 1.25. This is going to be the same as what we're adding. That's a plus 1.25 in a fraction form, same as 125 over 100. 25 there is what? 5. 25 there is 4, right? Yeah, that's going to be 5 over 4 u squared. The constant is only what? The constant is is a 10. I take it on the other side to be positive 10. Then from here I can divide by 10 throughout, everything by 10. That's going to give me, say what, you have a calculator, so 2.5 v squared plus 1.25 u squared is equal to 10. Then I'll divide by 10, divide by 10, divide by 10. This will give me 0.25 v squared. This will give me 0.125 u squared is equal to 1. And here you divide with these guys here, the reciprocals. So this is going to be an ellipse. Yeah, it's an ellipse. And you've cancelled these guys, the terms and everything. Yeah, so it's an ellipse. You can check it out, and this is the equation you're going to get. Of course, you can avoid these decimals by dealing with the same fractions and so on and so forth. But I just wanted to show you, so this can be written as 0.25 x squared plus 0.125 y squared is equal to 1. So you see that the x, y term has been eliminated. Have you seen what we've done here? Yeah, so it's a very, very long process. Yeah, but it's nice because at the end of the day, it will be easier for you to learn the next part, which we're going to have. I think we can do this on Saturday. We finish it off. Parameterization. Pardon?
So I need to figure out where, suppose whether it's rotation, those two equations. So I think I'm supposed to know those parts.
Oh yeah, you're supposed to know this part. So the question will tell you whether you are rotating or depends. So like I said, if there is an xy term where x and y are multiplying each other, you have to eliminate them, meaning you're rotating. This is what you use. But if the xy term are not present, then they want you to, it's like you're rotating it back to the origin. So if something is at the origin, you can take it back.
Okay, this way I just want to ask. If you say there's no x and y, so yes, there's no c, right?
Yeah.
It's going to be then in the written equation.
Pardon?
For example, okay, where there's the square root of 3, is it not is it the same one it's supposed to put? You mean, is it the same one you're saying that if there's no xy, you're not supposed to do that one?
Oh yes, if there's no this term, meaning you use this set of equations, meaning we have to bring it back. You use this set of equations, this one.
So again, angle, is it not also affected?
Oh no, the angle is going to be the same. You get it in the angle, you get it in a similar way.
We're going to have like C. Oh,
so whenever because the C is going to be 0, right? So whenever if you're trying to go back, the angle is always going to be 45. They use a 45, or it will be stated in the question. They have to give you an angle, and if they don't give you, use 45.
Alright.
Yeah, that's a good question. Yeah, I forgot to mention that. Yeah. Then there's also some part I had forgotten to mention on the parabola. I remembered when I was checking your terror sheet, there's what you call, I remember the directrix we said is simply what? Y is equal to P. There is a distance that we call lactus rectum. That's just the name that we follow. We say lactus rectum. So when they say what's the lactus rectum, the formula is just going to be 2P, 2 times the P that you get whenever you're doing your solving. Okay, you'll see such a question when we do the terror sheet. I just wanted to put it out there so that at least you've heard the name. Now when I explain it, when you solve the terror sheet, at least you know to say, oh, this is coming from where. Yeah, so this is what you need to know on eliminating let me give you a question. Yeah, let me even give you an interesting question at least.
But the asymptote.
Pardon?
Are we going to do the asymptote? Are we going to do the asymptote?
Yes, we're going to do them as well. Yeah, but not today. So yeah, let me just give you a question.
Alright, okay.
I want you to rotate it so that you eliminate the xy term. Yeah, so that at least, and you identify the same by rotation of the axis. So this is very straightforward. Let me just give you here this task. So the first one is x squared plus 2xy, then plus y plus 8x minus 8y. And the second one, okay, this is pretty easy, just, yeah, 5x plus 6xy minus 3y squared is equal to 24. Okay, so you can try this and then submit to me on WhatsApp, then I'll be able to see if you understand the concept. So we're trying to get rid of xy term. That's okay, right?
Give me also another that example. Since I've got those two equations, give me like a further so that I can even able to differentiate.
Okay, so
the question
here,
concerning the unrotated.
Okay, so rotation. This you are eliminating the xy term. Which one can I give you? The one where, okay, so let me give you something easy. The other one is where you're plugging it back. We need the angle, so it's like you are taking it back. So which one's down here? Oh, this one. So let me just say question 2. If I give you x squared 9 minus y squared, yeah, over 9, this is a special hyperbola where a and b are the same, at pi over 4, find the original equation. So this equation here is rotated. When you rotate it, it gives you this. Now I want you to go back. So the answer you're supposed to get, let me just give you a calicage here. The answer you're supposed to get is 2xy is equal to 9. That's the answer you need to get. Yeah, when you rotate it back. So yeah, this at least will help you understand. The angle is a 45 degrees. So yeah, this is okay, right?
Yes, it's okay.
Okay, yeah, so this is
it's okay.
Because there's a minus in between, this is a parabola.
I was expecting to be in what? The fraction form.
Yeah. Okay, so let's end here for today. Let's pick it up on Saturday, so that tomorrow I have these guys from Actuarial Science. So yeah.
Maybe Saturday, right?
Yeah, so
right.
We'll finish it off on Saturday. At least I give you time to assimilate this information tomorrow.
Yes, okay.